Hi friends, through this video we'll learn the notations and terminology which was used in queuing theory. We use the following notation and terminology. The first one is you have to know about line length or queue size. Line length or queue size is nothing but the customers in the system. It is talking about the length of the system. That is the number of customer in the system. It should be included the person who is getting service also and also the persons who are standing in the queue for to get a service both. If you are talking about queue length, it should be the line length minus the number of units being served. We already discussed about the queue length in the earlier video. The same thing here repeating, the queue length should be excluded the customer who are getting service. That is, if one person is getting service and four persons are standing in the queue means the queue length represent the four-person only. We no need to include the person who is getting service. The next notation is N. N denotes the number of customers in the system. Sn is a state which there are n customers in the system, and the representation Pn is a probability of a customer, that is n customer in the system. For example, if you are denoting P2 means it denotes the probability of having n customer in the system. Lambda and mu, we talked about this too the earlier itself in the characteristic of queuing theory. The same thing here, the lambda means mean arrival rate and it should be measured by the number of arrival per unit time, and mu is the mean service rate, how they are servicing, that is equal to the number of customer serviced per unit time. The next notation is rho, and rho is having a formula lambda by mu, that is mean arrival rate divided by mean service rate. It denotes the probability that the service channel is busy. It's also called traffic intensity, or otherwise we can call that one as utilization factor. In the problems they are asking find the utilization factor or traffic intensity or service channel is busy or somewhat terminology used means you have to find the rho value having a formula lambda by mu. And note it in the basic models, the rho must be less than 1. That is, the value of the lambda, the average rate, compared to the service rate must be more. Otherwise, the Q tends to increase indefinitely. The next notation we are using LS. Actually, L denotes the number of customers and S denotes system. So simply LS denotes the expected number of customer in the system. Next, we can call the same thing as expected line length or otherwise expected queue size, that is waiting persons plus who is being served. So that means it should be included the person who are getting service also. And in the similar way, LQ, as I told earlier, L is denoted as the expected number of customer and Q is denoted here in the queue. That is, LQ denotes the expected number of customer in the queue. It is only the waiting persons. The next notation is WS. The WS is equal to expected waiting time of the customer in the system. So W denotes expected waiting time. Here after, if you are keeping this one in your mind, it is somewhat good. Expected number of expected waiting time is denoted as W, and S denotes as system. That is, a WS denotes expected waiting time of the customer in the system. In the similar way, WQ denote expected waiting time of a customer in the queue if he has to wait. That means we are only concluding the persons who are waiting. We are not considering the person who are getting service. Thank you.